Hello, well then, welcome to Code or Not to Code. I'm Millie Eva and I'm very happy to be here today. And as always, I'm here with Stefan. How are you doing?
I am doing great. It's Inspector Roslyn time.
Yay!
Woo!
It is indeed. Oh my goodness. I actually love our new jingle. It's like always gets me a little like dancey and yeah. And I also have for Inspector Roslyn, I obviously have my trusty pipe here as well. So if we ever need
No,
to
you
really
do.
think about something, we can now do this. So that's so some props for today. If you're new to the show, welcome. And yeah, Stefan and us do meet every 2 weeks. Actually, we're really, really consistent now. I'm very proud of us. And yeah, we're building on Inspector Roslyn. We're coding everything live. So sometimes we do debug for hours, but usually we do have a lot of fun and we build some really cool stuff. And we always learn a thing or two, and this is what it's all about. So that's yeah, I definitely learn something new every single time. I think Stefan as well, and hopefully you too. And as always, if you are new, please take a minute to like and subscribe to any of your favorite social media challenges, because even though I did just say that we've been very, very consistent and good this season, we don't have the best track record when it comes to that. So please, like, you need to follow us, otherwise you'll miss the episodes, and then that's gonna be the end of the world. So do take a minute to yeah, to like and subscribe just to stay in the loop. Obviously, if you have any questions or comments, we always love to hear from you as well. And yeah, I guess hello Eric. I'm so glad to see you. And yeah, it's really good to have some regulars here tonight as well, and especially you, Eric, because we're going to start right away with some trivia.
Yes. Today's trivia is gonna play into, well, not quite a repetition, but more of a real life example of last year's April's Fool episode,
Yes.
where we did some shenanigans with module initializer and, well, executing some arbitrary code that could do some bad stuff. And, well, what we built so far with Inspector Roslyn is actually vulnerable to such an, well, it's an
Whoopsie.
arbitrary code execution. I'm not sure if this is a remote code execution vulnerability. Well, because we could execute somebody else's code off of NuGet, because what
Yeah.
we built in the last episode so far, let me enable that, is essentially we can go to NuGet.org and download a NuGet package in a particular version, and then run our inspector against this package and find all of the Roslyn components. When we run this, it will now find this package, and it will say this package has a suppressor with that name, which supports suppressing a diagnostic F0CA1707. No, actually, that's the ID of the suppressor, not what it suppresses. We can also find some analyzers, like an analyzer that warns if something should be checked with a pattern matching and with this ID, and so on. So we analyze, we inspect, we analyze analyzers.
Yes.
But we do this with reflection.
Oh.
And we load this remote assembly into our context. We actually, what's this very first episode? Where we, well, we haven't published any library or package just yet, so everything is good, but we gotta fix this. We are actually using the assembly load. So we are downloading this assembly and then installing it into an assembly load context within our process. And if our process runs, well, we plan to ship this as a NuGet, as a .NET tool, which runs in full trust mode. So now if this remote, well, I'm now saying not remote, I'm now going to a local component so we can simulate the problem. So we are now just finding a local assembly and installing, what am I doing wrong? And local assembly and finding all of the extensions in there, like here, this analyzer. Now we can go to this analyzer and do something, do some shenanigans. As in, because, well, what we do, we run the constructor of this type, but also properties. So what we could do is maybe in this get property or already in the parameterless constructor, like we could do something bad here or something here. Let's do console.writeLine property executed. And here, constructor executed. There is actually console.writeLine APIs are banned. So there is an analyzer when you build Roslyn components or compiler extensions that bans console, but it's just a diagnostic, so we can gloriously ignore it. Boom.
We know better.
Yeah.
And then
we built that now. And although this library or this is not run directly, it is, well, actually, we can show that if we shift F12 this type and find all usages are in test. We're not running the test project, we're running our production project, our console app, which doesn't have a direct reference to it. But indirectly, it gets the assembly that is produced here and then loads the type and initializes, creates an instance. So the constructor is run and accesses the property of this instance. So this getter is run, and we should now get constructor executed and property executed. And, well, we could do some shenanigans like create some stuff or delete some stuff. Maybe I say directory.create, and we say I'm not sure if this is actually a remote code execution, at least an arbitrary code execution was here. And if we go to our, oh no, I closed it.
But why would it be a remote code execution?
Well, I'm not sure if a remote code execution only qualifies if you're pushing code onto the machine. This is kind of pulling. I guess this may also qualify as a remote code execution. Well, we are executing code that lies somewhere else, so I guess it is, yeah. If we go to where's the tool? Where is the tool? Now a directory here should start popping up if I am in the correct directory. I'm not. What's the current working directory? I thought is this not doing something? Oh, do I need to build? I did build, right? Oh, I'm not sure what was wrong, but yeah, here it is now. Well, likewise, we could also delete it again. Delete directory.
Yeah.
And so currently it's here, and when we run this, it should now vanish.
No, all my files.
Yeah, but this could be doing some, I don't know, something like LLMs notoriously do, or not, well, tools LLM uses, like reading all your local files and sending it to some remote server.
Great.
So this is data could be extracted or something bad could be injected. So yeah, we are quite vulnerable to some remote code execution. And I'm wondering actually if...
But it... Yeah.
Go ahead.
Sorry.
No, go ahead.
So just to be fair to ourselves as well, like it would be like our tool, yes, would then execute it because you're inspecting this NuGet package, but you would already have, I guess, installed a dangerous NuGet package yourself. So that's you need at least two people to make mistakes here, right?
Well,
we are making a mistake, but you also need to, right?
I guess that's fair, yes. So I guess we would need to add a bit of a warning only run our tool on
Yeah.
trusted sources because we kind of trust the code and load it.
Yeah.
But maybe we could offer our tool as a bit of a
Some
safe
safety.
inspector. Yeah.
Yeah.
We
Ooh.
will lose fidelity, but we will gain security. And well, maybe at first,
I'm
since we
gonna
haven't
Google
published
what
it yet,
fidelity means
we
now.
like more. We won't be able to inspect as many details if you go a safer route.
Yeah.
But yeah, we haven't shipped it yet, so we're not really taking features away. And we can always edit back later when we have a better approach. Maybe we run it in some sandbox. I guess if we're in a Blazor application, we could run it in the browser sandbox. That should be a bit more safe. Or something like a WASM application, again, sandboxed, so that the bad code that can't really get out of the sandbox. But yeah, this is a more complex solution. We could offer that later. And are you still here? I see that you have left the session. Have you been attacked? Or is it me? Am I gone? Either Eva or I have connectivity problems. But I think it's you, Eva. Yes. Well, in the meantime, you're back.
Oh, surprise! I heard there was a loss of fidelity and I just left.
Oh, yeah. No,
Sorry about that. I do
thought you
have some
were
connection
attacked.
issues. I was attacked, yes. Oh my goodness. I just executed it. No, sorry about that. I do have some connection issues. This has been going on for a while because there's also a lot of building works going on in my building. But I'm back. You're not getting rid of me that easily.
Oh, I tried. What I'm now wondering if a module initializer would work as well. Ooh, I see Gerald is here. Hello, thank you very much for joining. It's been a while, but we met him in well, the two of us in Belgium almost a year ago.
Wow. A year
time
ago?
Flies.
That's crazy.
No, not like 10, 11 months, something.
Oh my goodness.
Let's see if I can remember. Well, we are on a Net Standard 2.0 library. So this module initializer attribute doesn't exist. I'm wondering if we can just declare it. Well, it needs to be in a specific namespace. So maybe let's just go to one of my favorite sites.
Source.net.
Yes, it's always source.net. And take a look in the private core lib. This is kind of the BCL. Or like the real core. This is in the core lib, this is where also the object lives. So this is where the most core types live. And okay, this is what a module initializer attribute looks like. Let's copy that because I think it just needs to exist. And then we should be able to use it.
Nice.
And we should now be able to do hello from module initializer. Because an assembly, oh yeah, again, it's banned because we're in a Roslyn component project. Console writeline is banned. We should now see, well, I'm actually not sure if this works, but what I would expect is that this now happens when we load this assembly into the assembly load context. But let's see if it actually does do what we run into, could not find part.
Oh, wow.
Oh, okay. I'm trying to delete a directory that doesn't exist anymore. This one. So yeah, so this works. And this is hello from the module initializer, which should now happen, as mentioned, when we load the assembly into our assembly load context. So this is exactly here. I do a before and an after, because this is where we load the assembly, and I think this is where it should be executed. And it isn't. Indeed. Wonder what. Oh, wait a second. Are we not hitting? Wonder what we are doing wrong. Let's take a look at our code. And we get the stream. Then we call this here. And this should go into here, should it not? Yes, and yes, and yes. But we don't see the before, after. Okay, I am quite uncertain why we don't see that, but we do see that the model initializer works. So yeah, which is coming from a different assembly that we load and trust. And yeah, this could, as we saw before, this could delete some files, add some files, mutate some files, extract stuff. Yeah, so that's bad.
Yeah.
And this will be a bit of a segue into today's episode, where we try to not do this via reflection and assembly load context, but do this instead via the Roslyn APIs, where we essentially create a bit of an in-memory solution into which we will add an in-memory project, into which we gonna add the project, also load the Roslyn component that we want to inspect as a reference. So essentially, and as if it was actually, I think our test project would be more depictive, because in our test project, we reference the Roslyn component. And essentially what we're going to do is we create a virtual solution with an in-memory solution with in-memory project that is referencing the Roslyn component in memory, and then inspect the types in there, but without actually loading them. So we are not running any constructor, we're not running any properties, we're not running any module initializer. So where there won't be any remote code execution, and our tool is safe again. And then this will be the first solution that we publish then in 2 streams, I think.
Yeah, let's see.
And then later on, we can think about a bit of a sandbox solution where we do the full trust mode and actually run the code, but in a bit of a sandbox environment, so nothing gets out of there.
Yeah. Okay. I still don't quite. Okay, if I just load it as a reference, I don't have any remote code execution. But why?
Well, if we don't run the code, we load the code.
Oh, we don't run it. Oh, okay.
But we are not. Well, if we were, because we are Roslyn, or we are using Roslyn, we could.
we are now, Roslyn. You're right.
No, we're not.
Surprise.
Or not quite.
Not yet.
Let's see. We could, if we now created this in-memory solution and project and reference, we could, of course, compile it to get a compilation, which we could then emit into an assembly, which again now we could run. So we could be doing what we now do via MS Build, where we build a project, then get an assembly out of that, and then load it via the assembly load context. We could still do this, but all based with the directly with the Roslyn APIs. So we could compile the project, emit the IL into an assembly, and then just run it. And then we have essentially this. Then we would have the same problem again because we would run external code.
Okay, but we just don't
We just
run
don't
it.
do that. Yeah, we don't compile it. We don't emit any IL. We don't run it.
We
We just
load
inspect it.
And
We just load it. Yeah.
Okay. I get it. Okay. Amazing. Good plan. And we're going to do that today in 2 hours. Is that the plan?
Yes.
Easy. Good. Amazing. How do we start?
How would you like to start? I guess we should start with a test, right?
Yes. Yes, of course.
I was experimenting with some stuff, and I got some failing tests, which is
no.
So.
Which is schlecht. You say that a lot lately. So if you don't learn anything else today, you'll learn some German words.
Yeah.
So schlecht is the opposite of good.
Yeah.
In case anyone was wondering. Okay, cool.
I just need to roll back some code because I broke a little bit.
Yes.
And get it somewhat to work again. Okay. Oh yeah, the model initializer was doing bad things. Let's roll back this. Okay, cool.
Always.
So let's see if the tests are a bit more green now.
Yes, please. Oh.
And
a bit more green.
Yeah, well, I was quite experimenting with them. I'm actually not sure how do we ignore or skip. Oh, there's an ignore attribute. Let's just ignore them for now. I was experimenting here a bit with some things, and I essentially broke them, but only partially. Shouldn't just change code just before going live.
Well, you know what? That's life, and this is live coding. so it's only this is how you guys know that we don't, we're not fake.
We failed quite a bit. Yeah, so we're agreeing with some ignores, but okay, cool. I guess that's a good start. And yeah, maybe we just, if we say we have our tests already, let's just rewrite our existing solution. I mean, we have checked it in to Git, so we could bring it back at some point when we got the sandbox going. But for now, essentially, what we're gonna do, we ban System Reflection API. Ooh, I wonder if we can actually ban it. Because we saw that within a Roslyn component, you can't do console whiteline because this API is banned. There is something called the banned API analyzer.
Cool.
Which is a project from Microsoft or from the Roslyn team. Wonder if where does this? Where would this be? Is this in Roslyn-SDK? No. Roslyn analyzers? Oh, .NET/Roslyn analyzers. Neither. Repository. Roslyn analyzers. Oh, it is .NET Roslyn analyzers. I guess I had a typo. This is also archived. No. This is now moved. Okay, this has now been moved to the Roslyn repository directly. So there should be something with Roslyn analyzers.
Nice.
There it is, the banned API analyzer. And do not use banned APIs. Yes. And let's see if we can get this quickly working. And okay, Microsoft.Codeanalysis.banned API analyzers. So we would need to include this project. Microsoft Codeanalysis banned API analyzer. Let's just check. Since we are kind of a bit in a security mode, let's just check if it actually is the project that we expect it to be. It does have a prefix reserved. That means it is something only Microsoft can publish NuGet packages that start with Microsoft dot. So this should be indeed good. And version 3.3.4 is the latest stable version. Let's include that. And I think from the setup, we need to add a band symbols text file and then add it as additional files. You usually add additional files so that Roslyn can see them. Because by default, Roslyn only sees C# files, but not like any file. So it won't see this text file unless we mark it as an additional file. Band symbols text file. And now in there, let's see how this looks like. Okay, in the format of, so we could ban an entire type, but we want to ban an entire namespace. So we just say n colon and then the namespace. So we would say n colon system.reflection. And now this should, if we set it up correctly, give some warnings.
Oh, I thought we had warnings as errors, but okay.
Well, we have warnings as errors in release mode.
Yeah.
We don't see anything, I guess. Not sure what we did wrong. Band API analyzer. We include a band symbols text file, which is also here. Let's do a .NET build on the CLI. Do we get the warnings? Oh, no, that's other warnings. Not sure what I'm doing wrong. It's namespace n colon n. Yeah. Oops. Eva is gone again. But I'm sure she'll be back momentarily. I hope I can figure this out. In the meantime, have to be added to any project referencing this package to enable analysis band symbols.txt file. We got that. You're back. Internet problems or?
Yeah.
I think you now selected a different microphone.
Oh, thanks for telling me. Is it now better?
Yes.
I'm back. Okay, where were we? What did I miss?
Nothing, because I'm still baffled why it does not work. For details on the ID string format, please.
System.reflection, right?
Yes. And it should be
System.reflection ban, I should say.
Let's see an example.
Yeah.
Let's go to grep.app and let's
that?
find. That's essentially a tool that indexes GitHub, and then you can search. GitHub super fast with that. And we could say filter by paths, find all.
That's really cool. Never seen this.
Band. So that's that's grep.app.
Yep, I'm already on it.
I use it quite a bit. And unless I'm using wrong syntax
for
here.
examples, that's so good.
This is, yes, but I'm doing clearly something wrong. Well, actually, it should be in the Roslyn repository because we saw that they are shipping some band APIs, so we should be able to find, there we go, band symbols. Okay, no, that's just how it is, T colon, and then Oh, maybe it needs to end with a semicolon. Or, well, I can imagine that the semicolon just denotes a comment. Or, well, that's actually not a comment, but I guess a message that is then displayed. But yeah, let's give that a try.
Yeah, definitely.
Maybe it needs to be delimited either way, and then we could say
in the... Yep.
No, not sure. System dot, do I have a typo? Probably, very likely.
What?
System dot reflection. System dot reflection n colon for namespace. Let's see if a type works. This would be the full type. Let's say, what is a type that we want to ban? The assembly load context, which lives in system.runtime.loader .assembly load context. Oh, okay. That seems to work. Maybe doing something wrong with the namespace. Is there like a
full namespace type thing? Or,
oh, wait a second. Maybe we actually don't use something from the namespace. No, system.reflection. If we remove it, assembly is in system reflection. That should be banned. Okay, but
that's a good shout.
Oh, wait a second. There it actually is. The simple assembly load. Oh no, it's a simple load count. Okay, not sure, but yeah, now we get warning every time we use this type. So maybe we also ban assembly. That's system.reflection.assembly. And yeah, now, it only maybe because it only complains when invoking members off of it. Okay. Since we weren't, no, actually we are, has been banned, but it doesn't show the namespace. No, anyway, not sure, we're not using the tool 100% correct, but yeah, we now get some warnings. So we can configure this banned API analyzer, use it ourselves. The way the Roslyn team is banning like console, whiteline, and probably other APIs, we can also use it in a project and forbid these. And yeah, so we can't use them anymore. If we do a release build, it would fail because we have warnings as errors. And yeah, now we need to do it differently.
Nice.
And essentially, yes.
Wait, is this our test, or are we still writing a test? This is the test.
Well, we actually have a test.
Can't do it anymore.
We are just changing. We still, we keep the public API surface the same. We're just changing implementation detail.
Yeah.
And I guess our test is, with the banned API analyzer, we now have some signal that forbids us to use reflection-based APIs. So we need to find a different way. Yeah.
All right. So let's create some in-memory projects.
We need to start with a workspace. Can you remember?
Workspace.
It's been last year when we started with some workspacing. Can you remember? You create an in-memory workspace, or how this one is called?
New
It's not quite called in-memory. There is an MS Build workspace that is essentially going off of local projects.
Yeah.
Like Solution, SLNX, CSProj, VBProj. Then there is a Visual Studio workspace, which only works within Visual Studio. And there's a third workspace, kind of the ephemeral one, which is called the ad hoc workspace.
Yes. There it is.
And yeah, we need to create a new instance of this.
Workspace is new.
Yeah. I would also, if new wouldn't work, then usually they have a factory method. Okay. Oh yeah, we need to dispose it at the end.
At the end.
So at the end, or with using declaration, which is inherently then disposing of it again after just before the method exits.
No.
Just a using at the beginning.
Yeah, but here left using.
No, at the very beginning.
No, very beginning.
We don't have the using with the new declaration because, well, this doesn't. Just the new itself doesn't have a name. We can't really refer to it. We need to give it a name. This is done via the local variable. So the using needs to be essentially modifying the variable, because what happens then, what this is turned into essentially is a try block for the entire method, and then at the end, well, it's a try finally actually, then does a workspace.dispose to ensure even if there is some exception within, starting from the using declaration to the very end. We could also use a using statement with which we can essentially define the block ourselves and then have it as such. And now we can ourselves define the end of the block, where this is essentially then a try finally for this block. If we just say using without the block, but as not the statement, but the declaration, then it starts here and ends at the end of the current block, which is the method for this. I guess you could also do a block around here. And now now we would create it and then immediately dispose it again, because that's the block.
Okay, so we've got our workspace.
And now to our workspace, we need to create what we essentially did before. So in like solution land, we would create a solution. Then we would add a project to it, and then to this project, add a reference. Now we need to do the same, but in Roslyn land. We don't need to add wait a second. As a workspace, I didn't know you can add solution.
I didn't know that either.
I did not know. I always thought a workspace is synonymous to a solution. Maybe it's not. Apparently, a workspace can have multiple solutions. So, okay, then the example I gave earlier was not 100% correct. But we don't need a solution.
Okay. Is there an add project?
So we just do add project,
Perfect.
I think we can give this a name. We can give this a name and a language.
Yep. Name is.
Well, we could use. I mean, we gave our assembly load context also a name, so we could just adopt the name here to have something similar. I'll just, if you don't mind, paste it into here.
Okay.
And
I'm already too slow. We're right at the beginning of the stream. No, we're not. Oh my goodness, time flies. All right. And we need a language.
A language, no. Yes.
Yes.
So Roslyn supports Visual Basic and C#. So we either need Visual Basic or C#. Yes. So you could write C# as language. A string. Yeah. Or you use, in language names. This should exist as a constant.
C#.
Yeah.
Yes.
And this is literally C#.
Okay.
Cool. Now we have a project. Now to this project, we need to add our Roslyn component as a reference.
I was just going to do it like this. Add.
I wouldn't do
project
it
reference.
the other way. Yeah, it sounds promising.
Ooh.
Now, what does project reference take? It takes no, wait a second. Oh, not a project reference, because that's a reference to another project. Are there other references? Maybe you can search
Analyzer
just for.
reference.
Yeah, no, because we're not adding.
Metadata
Well,
references.
no. In this case, since we don't compile it, we don't add an analyzer reference. We just add it as a library. So there must be something like. Oops. Cool. Now my Visual Studio crash. My write-up was freezing.
Haha! Oh. Why am I happy about this? I'm not the only ones with issues today. Yes, metadata reference.
Metadata reference sounds promising, yeah.
Metadata reference. All right.
And this one takes a metadata reference. So now we need to create a metadata reference.
Oh,
Metadata reference is an abstract type. And usually
Yeah.
when there is an abstract type in Roslyn, then there is factory methods on that abstract type.
nice. Metadata. Oh my god. Reference. Dot. Create
What do
from
we have?
stream, create from file, create from image, create from assembly.
Okay, create from assembly is marked
Oh,
obsolete.
I don't have
And
that.
we would use, if we have an assembly, then we would need to load it. So we would violate our banned APIs. Well, stream looks like
Stream is good.
fits to our current API shape.
Fits. Oops.
And this is indeed just take a stream and that's it. It takes a stream, also some potential metadata reference properties. No idea what do we have in there. Oh, we could say whether this is a module or an assembly. And, aliases. I think, I'm not entirely certain if this is what I think it is. I'm not sure if I find the documentation now, but when you import a NuGet package, I'm not definitely getting this wrong. But
Okay.
something in that term, because I'm using it super rare, but something in the term, if you import a NuGet package,
Yep.
you can say something like, I'm not getting this wrong, something like an alias. And then later on, when you import types from this package, you can then use this alias. You kind of need this if you import two different packages that have, for example, the same type in the same namespace. Maybe two packages have namespace A type B.
Yeah.
How can
I
you
think
now
we had that in one of
differentiate
our talks
between?
as well. Right?
I can't.
Because we
Maybe.
can't. And
Maybe.
then I can cheat you with my namespace that's called exactly the same,
Yes.
but it's like
And-
closer.
Yeah. And if it
Oh,
is
we did
coming
this
from-
also last year, 1st of April. I think. Oh, we didn't. Did we? Okay, I
not
can't
sure.
remember.
It's
I can't
been
remember.
A year. I don't remember.
It's been a year. I can't remember what we did 2 weeks ago.
That is dramatically correct. Aw.
Oh, this is exactly. You think we're doing this for our viewers? We're actually doing it for ourselves, just to refresh, and then we record all of our sessions, so we can go back and be like, okay, what did we actually do?
Yeah.
Yeah. Okay.
Yeah. So I think if
Aliases.
this may be, if this is what I think it could also be something different. The aliases here. It could be that, and then also embed interop types, which I have absolutely no idea what that means. So we may, since I think, well, this is an assembly that we'll be loading, I think we can pass, this is static, metadata reference properties assembly to be most explicit. Unless it actually does what? Yeah, create from stream. Yeah, let's do that. So let's pass also, what was that? Metadata reference properties dot assembly.
Okay. Yes.
Yes. Oh yeah, you're there.
Metadata reference. What?
I'm not sure if I remember the name correctly. Metadata reference properties.
I said I can't remember what we do last week. I can't remember what you said two seconds ago.
Not quite.
Is that
So
the
this
right
must
one?
be
It's not the right one.
metadata reference dot assembly, this one.
Assembly. Yeah, I just didn't want to write it out because that would have been a disaster and 15 minutes of our time. Okay, good. Cool.
Cool.
And
Now we need to store that metadata reference into some field and a local, and then pass it down.
Called what exactly?
Oh, wait a second. What does add metadata reference return? That returns a new project because everything in Roslyn is immutable. So we just replace. Sorry, that was wrong. We need to replace the existing project with that. Yeah, because everything is immutable. So this is essentially a new project that we declare. So we say project equals whatever is returned here.
Okay.
So we reassign.
So we get a warning.
Yeah, because we currently don't use the return value. Oh. And so this is essentially, this is now creating a new project which has this metadata reference, but we are immediately discarding it. We're not assigning it to anything. Okay. Yes. So we just, we could create a new field, call it project with metadata reference, but we don't need the one without. Yeah. So we can just replace the existing or overwrite the existing one that we have.
Cool. And now we can use it, right? No?
No, we are not yet. So, okay, what we need to do is that.
Okay, got it.
Now the warning goes away because, this is returning a new project, and now we replace what we had previously, the one without the metadata reference, now with. And yeah, this is now a project that has this reference, and now we should be able to, via that project, find the types.
Yes. Project find types. Project dot find types. No. Get type.
Yeah, no, it's not. It's of course. This is the get type of object, so this won't work.
That's too easy. Okay.
Now we need to get a bit more familiar with the structure. So when you compile a project, you get an assembly.
Yes.
And assembly can contain one or many modules. And within these modules, we will have our types.
Mm-hmm.
So we need to kind of walk this hierarchy, get the assembly, get the module, get the types. So is there something like assembly something?
Assembly name. Didn't work. Oh, it did work. Did you do that?
Oh. Maybe.
Okay.
But I don't think that's the thing we need.
Okay. No. Okay. What can we get? Compilation.
Do we need to actually? Oh, maybe we need to compile. Yes. How can we get the types without a compilation? Yeah, we actually need to compile. Yeah. Yeah, you're right.
Okay.
Yeah. So cancellation token. This supports cancellation. So we may want to turn this into an asynchronous method. Now this will break our existing code. So let's.
Mm-hmm.
Let's just. Would you mind turning this into an asynchronous method?
Mm-hmm.
And I'll do a synchronous wrapper.
What?
So just turn this to an asynchronous method. And usually when you have an asynchronous method, you also the name then also should end with async.
Now I get it. Yep.
Result, yeah. And then we need to return a task of that type. Or a value task of that type. But considering that runtime async is on its way, and I think the general suggestion will be just to use task. Never mind. I was going a little bit myself off the road. Yeah.
No.
And yes, and I think it's just a warning. Consider calling configure await.
Oh.
And this also supports cancellation. And usually when you have an asynchronous method, you also pass as a last argument or as a last parameter an optional cancellation token if you do want to make this operation cancelable. And yes, exactly. And then we can pass it down or forward it. Wonderful. Cool. This is just like a synchronous version, which just does dot result. So it's just blocks. This is bad.
Yeah, this is bad.
This will just be a temporary workaround. We shall remove that one. Well, if the consuming code wants to do that, then sure. But yeah, our library really shouldn't, because, well, if our library implementation does nothing but just waiting, yeah, then it doesn't really add any benefit. If we would do something smarter than that, then yeah, sometimes it does. For example, HTTP client. Now also in newer versions of .NET also have synchronous overloads, which I think are more than just blocking, just calling the async method and blocking. I think on some operating systems, I'm not sure about the implementation detail, but do actually something more smarter, something more efficient. But yeah, so this should be gone again eventually. Cool. Now with the compilation, maybe we can ask the compilation for the assembly symbol, because everything is a symbol when it comes to compiled things.
Yes. I know. Anyway, we have a couple of symbols things, but get assembly or module symbol.
Yeah, let's try that. Now this so this returns a symbol.
Yep.
So I guess this now could be either an I-assembly symbol.
Yep.
Or an I-module symbol. And both of these inherit from symbol, so it's either one of them. I'm not sure if we need to. Maybe we need to check.
Is there no normal just get assembly? No, there isn't. I thought maybe I missed it. Okay.
I'm now wondering. I thought maybe again I don't understand assemblies correctly. Well, not maybe, but very likely. I thought that there is always one assembly which has multiple, or may have multiple modules. So I guess we could do a type check and see if the return symbol is an assembly symbol. Let's go with one for now. I guess later on we should kind of support both. I'm not sure if there's a scenario where it could be either, or if it's always one of them for our scenario. I'm not quite certain. But just to be a little bit on the more defensive side, maybe we should just offer both paths so we are more safe. Yeah.
Is type of...
Oh, no. If you do an is check, then you can just mention the type directly. Because when you do something with is, that's statically, it needs to be a static pattern.
Assembly.
When you do type of, then some dynamic. It's more dynamic, and this wouldn't work.
Okay. Oops. Where am I? Oh, here. Sorry. And
this
we
takes...
need to pass
we need the metadata reference.
Oh my goodness.
So this doesn't get... Oh, right. Because what if we have a project that has like 7 references?
Mm-hmm.
Which assembly do we want to get? So we need to pass down the metadata reference. So we actually need to store the metadata reference that we create here into a variable and then pass it down to
metadata
the
reference is thank you. And oh my goodness, it's here. This all changed. No. Yes. That's add metadata reference, and then metadata reference create from stream. This one is what we need, right? Okay.
Yes. I wonder if the shortcut works for you. If you do, well, I guess, does it work for you, the shortcut? So to expand selection, if I hit Control Alt, well, on my German keyboard with my setup here, if I hit Control Alt plus.
Oh my goodness.
Oh no, not Control Alt plus. Sorry, Control Alt right arrow, I can essentially expand the selection. So first from the type to the method, the entire line, the entire scope, and so on, and then go back again. I was wondering, does this because I use this quite a bit. Does this work for you as well? It seems
Control Alt. No.
Control
Yeah.
Alt, left and right key.
Woohoo! It does indeed. Amazing. And if you haven't been like when Stefan and I first started, this is what we did a lot of the times, because when we started this live stream, I just started like coding, and so I did everything with my trusty mouse, and then we just worked on my shortcuts for an episode. So yeah, back to basics. Lovely, thank you.
I'm still working on my shortcuts. I got a message the other day from a viewer that I'm not using all of the wider shortcuts.
Uh-oh.
It was a good reminder. It was a good reminder.
Yeah, they do save a lot of time.
Indeed. And potential errors. Cool. So we can pass the metadata reference down to this method.
Yeah. Yes,
and
yes.
Maybe let's do a bit of breakpoint debugging and see how far we get. Well,
no, I did it wrong.
This anymore.
What did that? Oh, like this.
Let's see if we actually go in there or in there.
You can take your bets now. Oh, oops.
I would expect an assembly symbol, but I maybe...
Okay.
Well, it's a 50-50 chance.
Then I expect the other thing.
It is. Okay.
You win!
So we can now store this into a local variable. And now from there, we need to explore all of the types. So I guess, well, since it's assembly, I think this one now has... I don't think we can get the types here directly. I think now we need a module or something. Oh, we need the global namespace. So what do we have? We have essentially containing namespace. The global namespace. Okay, what I think we need to be doing is essentially now scan all of the namespaces. So there is the global namespace. And in the global namespace, we now have namespaces like system, which has another namespace like reflection, and so on. So I guess we need to have some recursion or some loop going on that goes through all of the namespaces and through all of the types, because it could be that the analyzer we are searching, well, this one is in this assembly. In this namespace, but I could remove it. Now it's in the global namespace. So yeah, we need to scan all of the namespaces because we don't know where the user will put it into. So I guess, we take the global namespace.
See.
Does the global namespace now has something with types? I would hope so.
Yes, wait, type, get type, containing type, get type members.
Type, get type members sounds, yes. So we get, yes. And, but I would assume that the namespace also has more namespaces.
Oh, no. I mean, great. It's global.
Get namespace members.
Lovely.
Because these would be the type members or the types only in the global namespace. But there are also namespace members. But let's start with the global namespace, and then we see how we can turn this into a bit of a, not necessarily recursion, but a bit into a loop.
Okay. Wait, so start with
Let's start with the, yes.
Okay.
Well, we won't find it in there, but let's get started here. So now we need to iterate through all of these type members and essentially do, essentially we then need to do this logic to go through all the types and find out what they are. But let's do this in here. So maybe here we extract a collection of all of the types that we find.
So we need a collection.
We could do two things. We either store them in a collection that we just add to, or we use an iterator method. So we produce an enumerable that we then
that's what I want.
Extract later on, so we can get a more linky style.
Linky, it is. We want linky.
So for that, we can do another method.
My formatting is crazy. Another method inside here, outside here.
Outside here.
Outside here. Yes.
So let's just create a private method.
Private.
So,
oh, you do it. You do it.
I'm not sure where you are.
No.
Oh, I can just follow you. Oh, I don't see there you are. Yes.
No,
go ahead.
Oops. I'm breaking my if condition. I'm good.
Let's write a new method.
You wanted to create a method.
No, go ahead.
You wanted it somewhere down here, like a helper method, or within here.
So just below this method.
Below this method.
So
here.
Yeah. We can then also later on.
We found each other. I just
did. Also later on then put it into a separate type.
That's good. You might have excommunicated me. I did some spaces. I'm sorry.
Well, we have auto formatting, so yeah.
We want a private static. Static? Yeah. What are we returning?
If it's an iterator method, then it returns an enumerable. Yes, exactly.
Of type.
I type symbol, I think.
Type symbol.
The type would be the reflection style type.
Yeah.
The Roslyn style type is the I type symbol. Yes, and we pass in an assembly symbol. And then in there we would find, or we essentially do what we have here. We can just move that down. I do that if you don't mind.
Yes, do it, please.
And then just yield return each member.
Okay. I hate this. Yield return member. Easy peasy, lemon squeezy.
But now we only go through the global namespace. So now in the next step, we need to for each over all of the namespace members. So essentially create another for each that now goes.
But in here, get types? Oh,
yeah.
No.
Yeah.
Why is this so difficult to format? Sorry.
Yeah,
I break everything. It's so ugly. Okay. For each well, I guess member again type member. Should we call this differently? I don't know.
Doesn't matter too much. Super small method. But yes, so we now go through all the namespace members.
Yeah.
This is now another. Okay, this is now a namespace symbol. So we could now get the recursion going by not passing an assembly symbol here, but actually passing a namespace symbol. And then just pass the global namespace down from the caller. So we would then say here, get types, passing the assembly.global namespace, essentially like our starting point. Let's fix that later. And in here now iterate through all of the members. Would this work? Now have another for each, which calls get types.
For each the type in get types? Yes.
Yes. And yield return the types.
Yes. Do you know what the most annoying thing is about this? When I click enter, for a brief second, I don't know if you see this, it has the correct formatting, and then it just removes it. And then I'm like, now I have to put it back. But it's okay. I'm calm.
Can you do Control C so that it goes back to the what it was originally?
I'll try
Not
next.
sure.
I'll try next time. All right.
Cool. Yeah, this should now, we may have made a mistake, but this should now, we go through all of the global types and then
Yes.
all of its namespaces. And then for each namespace that we find, we go in here again, now get the types of this namespace, for example, system. So we get off the system types and then go through all its namespace members, which is system.reflection, system.memory, system.runtime.loader, or was it loader.runtime anyway? And then this should now go through all of the members. So we now have an enumerable that we could now, if we now change our...
Wait. I'm confused.
I think you're frozen again a little bit. No, you're back.
Am I frozen? Woohoo!
You're back.
I just the freeze. Wait. Oh gosh. Like when I'm thinking about like recursion, I always. Oh, but like, how do we get each? Okay, I think. Okay, let's just try it. I think we're good.
No, what's not sound?
I just need to like go over it in my head, like step by step once. So
right. Well, we can. Let's later. Let's actually. Yeah, let's do that.
Do it later.
Let's step through it. No, actually, let's. So I'm just getting it to compile.
Thank you.
Actually, it should. Return statement is missing. Well, yes. Then let's throw. Boom. Cool. Let's actually go through it and let's see what will happen.
Yes.
Let's start here. Oh, haha. We're just returning an enumerable, but we're not observing it. So yeah, this won't do too much. So to actually get something going, let's just for each, or let's say to list. This will materialize it to array. This will materialize it so the iterator method would actually walk through, because we would otherwise just stop at the first. No, nothing would be run, because we need to call for each we need to call the move next, so that the iterator method is actually went through, and immediately get an aggregate exception, which is the method operation is not implemented. Oh, wait a second. Are we now hitting?
What?
Are we now hitting this one?
Oh, that's sad. Hello.
No, we are.
Oh no.
Why is? Do we have another? No, this should just. Okay, something I don't understand. Why does this not go? Where's the breakpoint? The breakpoint not hit. They're not. Wait a second. There's the global namespace.
Yeah.
And if we say, well, this should now go into get types. Does it not? Yes. But now we are. Why does it not enter? Interesting. Not sure. What is going on? Oops. Just shuffle the code around a bit. No, there's something wrong. Something's wrong with the breakpoints, or with the Okay, yes. Now it would be great if you go into, because for each over there get types. Now this should hit any of these breakpoints. But I am super uncertain what's going on.
Okay.
I was hoping that this method would be invoked, but it's an iterator method, and we have a bunch of for eaches. Well, of course, they wouldn't be invoked, but we will materialize them with the to array. So I was hoping.
That's weird.
Good old. Oh, no.
Yes? That sounded so hopeful.
It doesn't never hit, interestingly. Okay. Let's start from the beginning. Now that's embarrassing. I'm not sure what's going on. So we call into our inspect method. Yes.
Yes.
Now, okay, this is calling to here.
Yeah.
Then it does some stuff, and it should then go into here. Unless, oh, maybe it doesn't.
Yeah. Maybe we run into an exception before. No exception.
952. Does the console
line
network?
52.
Which is okay. So yeah, we actually. So it seems to be. I'm not sure. Maybe our breakpoint was misleading. Something's going on. It actually seems to be a module assembly. How could we do that? I'll just extract this into a variable. Let's call this assembly or module symbol. And if it's a assembly, then do that. Or if it is an iModule symbol, then I wonder if the same code would work. Okay, cool. And otherwise, just from sanity, this should be unreachable. I'm not sure what was auto-completed here. Something weird was auto-completed here. Now we should go. Okay, apparently it is a module symbol.
Yeah.
Now our, not sure what I was doing wrong with debugging. I thought it was an assembly symbol, but it seems to be.
Oh, value is not accessible. Why?
Maybe that's called something wrong with the synchronous version. Oh, maybe. Oh, maybe the debugger has issues when. Oh yes, because we block this. This blocks, and then this blocks the current thread, and I guess this messes with debugging. Probably. Let's call the async version. Yes. Okay, cool. So, wonderful. So we are now coming from the module symbol, and we pass in the global namespace. And like, if we jump into our project here, well, there is a global namespace, but there won't be any types in the global namespace. So I would expect none to be found. Then it goes through all of the namespaces. Not sure if this is sorted alphabetically or in some fashion. So there is the namespace flashover.
Yes.
It won't find any types in the flashover namespace. Then there is the namespace code analysis, which is in the namespace flashover. So it's really kind of nested. So there's namespace flashover. Then in the namespace flashover, there is the namespace code analysis. And in the namespace code analysis, there's the namespace demo and so on. So yeah, when you write code like this, the long fashion would be if you would write it like such.
Yeah.
So those are all nested demo, namespace, diagnostic, and then, well, now I would move this type into here, and the shorthand is just using the dot to essentially nest the namespaces. But there won't be any type in flashover namespace. There won't be any type in the code analysis namespace within the flashover namespace. There is no type in the demo namespace within the code analysis namespace, with the flashover namespace, within the global namespace. The global namespace is kind of the root. But there will be a type in the diagnostics namespace in the demo, in the da-da-da-da-da. And this type will be the C# diagnostic analyzer. But it could be that there is a type in the flashover namespace, or it could be that there's a type in the global namespace. So we need to traverse all of the namespaces and all of the namespaces that a namespace has, and then get all of the types there. What we're currently not considering are nested types, because we can not only nest namespaces, we can also nest types. But I think we have a test for that, so we will cover that later. So we probably also need to deal with, oh no, Eva is gone again. So it's definitely a to-do. Eva's back.
I do hope it's the last time. I don't know what's going on. Sorry.
It is the wrong microphone again, I'm afraid.
Hello.
Yo.
Yes.
Cool. But now let's go through that. So I guess we won't find any types in the global namespace. Oh, wait, there are. Module. Okay, there is a module type. Not sure what it is, but okay, we'll find it. Now we jump to the entire enumerator. Let's maybe not do that. Let's just do breakpoints all over the place and then F5 through them. Okay, so now we found some module type. Now we go through the namespaces of the global namespace. For example, the flashover namespace.
Yes.
And now in the flashover namespace, since we now have the recursion going on, we now find all of the types within the flashover namespace. We didn't find any. So in the flashover namespace, we get now its namespace members, which is flashover.code analysis. We won't find any type in there. So again, recursion going on, finding now all of the namespaces within the flashover.code analysis namespace, which is now flashover.code analysis.demo. And we won't find any type in there. So again, all of the namespaces. So demo.diagnostics, but in there we will now find a type. So again, recursion going on, we pass in that namespace, but we will find a type now, and is indeed our C# diagnostic analyzer demo. And I think there will also be another one, C#, that was this one. There is another one, C# diagnostic analyzer demo. No, should be the suppressor. Okay, not sure. But we'll find multiple types in there.
Yep.
And, there is the C# diagnostic suppressor, yeah. And so on and so forth. And now we go through all of the types in this namespace, and then with the recursion, all of the other namespaces. So we traverse all of the namespaces and all of the types. But we only get top-level types. We're currently not inspecting nested types. But yeah, we can do that later. Does this now make more sense, how this is working?
It does. Yep. Thank you. That helps my brain a little bit.
Oh, yeah. But we still have a lot to do. Let's tackle that later. And yeah, now we can, since we essentially now extract here an enumerable of these types, we should now be able to, well, get compiler extensions out of there. But we no longer have any, we don't have an array, we now have an enumerable of I type symbols. So we now need to rewrite this code, and then I think we may be good to go. This is no longer working, but I hope none of our tests is depending on this. They probably are. Yeah, we may need to do a bit of restructuring of our test suite. And yeah, we don't need this anymore. So now we are no longer working types, but I type symbols. And now essentially we need to rewrite our logic to not work off of the reflection type, but the Roslyn type or the Roslyn compilation type. Can we find out whether this is a class or a reference type? There must be some, there should be some equivalent. Maybe class or reference type, or is it like, does it have like struct and we need to negate it?
It's reference type.
Yeah, let's use that. Cool.
That's good.
This is essentially saying if it's a class. And checking if it has a name. Maybe we don't need that, but okay. So we know this is not nullable. So a symbol always has a name. Is that true? Because there is also a I named type symbol. But okay, I guess we don't need that check because we seem to always have a name. It's not nullable. So I guess we can just kill that check.
Woohoo! Oh, I should have used my new shortcut power.
Yes.
I do apologize.
So now we need to check, is this type
Yep.
derived from diagnostic suppressor type? I think a type is a base type.
Yes, it does.
And
it just got rid of all of this other stuff. I'm not going to remember the name, but I've got you, Stefan. You're going to help me.
I opened the source control diff on the right-hand side. So
my goodness.
The thing is,
we could just do it like this, and then it shouldn't break.
The thing is, it could also be recursive. Not recursive, but the base type could be another type that eventually derives from diagnostic. But yeah, for now, let's just check the base type, and later on we need to check the base of the base and so on. So let's check.
But we don't do that now? We can do that now. Or is it too long? We're trying to be very respectful of time this season as well. So
let's do first the base type check, and then immediately we follow up immediately.
Amazing. Okay,
the
base
question
type.
Now is, how do we check if something is of a specific type in Roslyn? There is something like a type comparer, I think. Compare. How is the comparer called? Well, actually, how does this? I forgot.
Match type?
No, maybe, but I can't recall. Okay, check if a type is a type. I should remember. Type comparer names. Well, because base type, that's a named type symbol, and we can't say type of, because type of returns a system.type. How do we get the Roslyn type? We need to ask the compilation. Don't we have the compilation? Oh, maybe we need to pass down the compilation that we got. Compilation. And ask the compilation as something like get type. Get type by metadata name.
Okay.
And the metadata name for diagnostic suppressor is microsoft.codeanalysis.diagnostics.diagnostic suppressor.
Nice.
If this was a generic type, then it would be backtick 1. Well, if it was a list, the namespace name of list is system. The metadata name of list is system.collections.generic.list backtick 1, because it is single generic. It has a generic arity of 1. Dictionary, on the other hand, has a generic arity of 2, because the T key and the T value, so that's backtick 2. So if there is a backtick, then the number denotes the generic arity. If there's no backtick, then it's non-generic.
Nice.
And so this is essentially then the suppressor type that we are searching. And we can't just compare them, but I hope there is a diagnostic for that. Yeah, there is a diagnostic for that. The symbol equality comparer, and this is what I was looking for. This is the one that we need to use.
Nice.
So we can now compare if, well, first of all, this may return null.
Uh-oh. Okay. Now
which means that this type isn't found.
Okay.
So if we don't find that type, we need the type, otherwise this wouldn't work. So maybe we can even, this is our tool. We should have this type available. So if this is null, I would throw an invalid operation exception. Oops. Yeah, backtick 1 will not be found. Not found. This should not happen. We should actually have the type available. And what am I thinking about?
I don't know. So if it's found, then we go.
So this should be found because we need the type available. We host the Roslyn compiler, so we should have this type available.
Okay.
And then we check, is the base type this type? And if it is, then we can do the next check. Then we can check.
I did something wrong again. Thank you. I don't know what I pressed. Sorry.
Then we can check if the attribute is on that type. Now, I guess this is very similar. Is there something like attribute types or something?
Get attribute and get custom attribute.
Get custom attribute?
Custom? Okay.
Yeah.
Okay. Custom attribute.
No, wait a second. Ooh, that's attribute. Gets the attributes of that symbol. What's the other one returning?
A bool, I think, is it? No, it takes what? Get custom. I'm confused. Why doesn't it exist now? Do you also get red? Yeah.
That does return.
No.
Oh, yeah. Maybe because of that.
I broke something. I'm so sorry.
No worries. Type dot.
Yeah. Try again.
Custom attribute.
Yeah.
Oh, yeah.
Oh no. Okay. It wasn't me.
There's something weird. Why does it cannot resolve? Okay, cool.
Okay, so get attribute.
Get attribute. Oh yeah, there is something. Oh yeah, it says they are not found. Yeah, it's get attribute. Yeah.
Okay. Cool. Okay. Get attributes.
Get attributes, and this returns attribute data, and this attribute data now has a attribute class with which we can now again compare against. So let's also get, so we also need to get the namespace name of the, or the metadata name of this attribute, which is this. So this is now the suppressor attribute type. And likewise, we now need to check if any of these attributes, so we can do some linking.
Oh,
If
yes.
any of these attributes returns true when invoking essentially the equivalent of that, of the symbol
Okay.
equality comparer.
So here we need the link thingy.
No.
No.
Get attributes returns an array. So we need to do that on the array that is returned.
Oh,
That
my
method
goodness.
doesn't take a lambda that allows the filtering.
Okay. Okay, that's fine.
Not sure what to do.
No.
So this returns get attributes
Yeah.
returns an immutable array,
Okay.
and
so,
immutable array eventually implements or has extension members for link methods. So on the
Oh.
returns type, we can now say dot any.
So we can we chain it though, or do I need
Yes.
to put it in a variable? Okay.
No, just chain it.
Easy peasy lemon squeezy. Any. Yes.
And now for each of the elements in there, we want to check if the attribute class equals what we extracted up here.
Yes. No. Do we now need the funny lambda syntax and stuff?
Yes, we do.
Okay. Oh.
Because any takes, well, not necessarily, but any takes there's an overload that takes a function.
I'm getting a code suggestion, but I'm too scared.
Let's try it.
Okay.
Yeah, that looks good.
Oh, really?
Yeah.
But
yeah, it looks good.
it doesn't look like anything that I would have written, and that really annoys me. Yeah.
That looks good, yeah. Because it now checks
Okay.
if the attribute class of any of these attributes equals to, again, the type that we extracted up here. Oops, up here.
Okay, great.
And if it does, then not constructible. Not constructible is a check. I guess we need to check this one as well. So we pass in an I type symbol in here. Okay.
Oh, good.
I type symbol has a check if it's abstract, but we need to find out if it has an instance, a parameterless constructor. So can we check the constructors on this type?
Goodness. Type dot constructor. No, that would have been too good.
What does it have? Something like constructor? Oh, no, there isn't. Well, a constructor is also just a member.
Oh, perfect.
You need to find all of the members.
Get type members or get members?
Get type members would be nested types. So just the members.
Yes.
And the members of, yeah, those are now more symbols. So again, we can do some linking. If any of these members, I wonder if get members has an overload that takes something to filter by. No, well, we can do a name. Oh, we can check by name. This would be a bit of an optimization, but let's check that out later. So now, does any of these members is a constructor? So there may be something like a member kind or something, or member type. Usually something
like
with kind in Roslyn. Yeah, can we check if there is something like a kind?
Kind?
Yeah,
kind?
Well, and yeah, so symbol kind, and we can check if the symbol is a method. Does it also have constructor? No, it doesn't. Well, constructor is a method. So we can we need to check if the kind is a method.
Is symbol kind Oh my goodness. There's so many. Method.
Yeah. And
Yeah. Oh no. Okay, I can do end. Oops.
is there maybe
can't find
something
the
that
pipe
says if
still,
it's a
but-
constructor? No, there still isn't. How can we find out if this method is a constructor? Well, maybe we need to cast. Maybe we need to check if this member is there something like an I constructor symbol? No, there isn't. How can we find out?
Okay.
Well, does a constructor have just the same name as the type it contains? Maybe that's how we find out.
Oh, yeah. Right?
Probably.
That's smart.
So let's check if the
Cool.
name is the same as the name of the type.
Name of.
Not name
Type.
of. Name of is constant, but this is dynamic. So that's the
Okay.
type dot name.
Okay. Type of name. Easy.
Yeah. Because if you would be doing type
Yeah.
of name, this would always be just name.
Yeah.
Cool. And also if this method doesn't have any parameters, because we are looking for a parameterless constructor.
That's true. And x dot. Oops.
Is there something parameters?
Oh, no.
Oh, wait a second. That's argument. No, parameters.
Nope.
Oh, now we would need to do some casting because, well, we know it's a method. So now we should be able to cast this into a method symbol. So let's cast this X into method symbol, or into I method symbol to be precise.
Oh my goodness. I method symbol. Just how does it work? Like this? Other way around.
Yes.
Ah, damn it. Like this.
No.
No?
You have the parentheses around the type you want to cast to.
This. I want to cast to I method symbol.
Yes.
And then I have the X.
Yes. but
Afterwards.
after. Yes.
Oh, that was it.
Since we want to invoke a member of the type I member symbol, we need to put another set of parentheses around this.
Yep. Oh my goodness.
And now we should be able to say dot parameters.
Dot parameters. Yes.
And
is
see if parameters
count
is very likely
is
and
null.
immutable. Exactly.
0.
Zero.
Really?
Yes. Yeah. Well, length.
Ah.
Okay, because it's an immutable array and that's fixed length, so it's length.
Okay.
There may also be an is empty. Immutable array, I
Ooh.
think, has something like is empty. Or is default,
Is
something
empty?
like that.
Oh, default or empty.
Default or empty, yes.
And we have also is empty and is default. So
Oh, okay. Well, we can, with is default or empty, we should be super safe.
okay.
And if this is default or empty, yes, then it is that this would be finding the parameterless constructors. So I hope. So I'll be just cutting that, moving this
Oh
into
my
the
goodness.
is constructible check down there.
Yes.
And this should be the equivalent of us finding instantiable types, because this is what a cosine component must be instantiable, otherwise the compiler at runtime can't run the code.
Yeah.
Cool. And yeah, we'll be just commenting out all of the other types that we have, like code refactoring providers, code fixers, source generators, diagnostic analyzers, because, well, this would be just the same pattern all over again. But let's complete one. So we no longer, this is what we don't want to do. We don't want to create any instance. Now we know that this is a suppressor because it is, well, the base type is implemented. Where are we? Yes, the base type is implemented. It has the attribute, and it has a parameterless constructor. And yeah, now we need to get, now we run into a problem because our current structure, like suppressor info, is, well, it's getting a type and it's using the attribute, an instance of this attribute, which we don't have anymore because we don't instantiate stuff. And also an instance of the suppressor descriptor that we do not instantiate anymore. So just to get something, I guess we need now a different hierarchy. I don't want to get too much breaking, so just add a new type. Let's call it suppressor Roslyn info, because that's now what Roslyn is exposing. And well, we no longer can really get a type. I guess we can get a name, and we can get, what can we get? Maybe of the attribute, we could get the language.
Yeah.
So maybe let's start with these two, and then we see what we can extract more. Yeah, this quite won't work anymore. I'll just add an empty constructor here. This is just some, we will delete most of that code, but just to get to something compiling quickly. Yeah, this is lying because this may be null now, but let's not care about this for now.
Yeah.
Oh yeah, you changed it, thank you. And then we just have a name and a language. And cool. And yes, now we pass in, now we need to pass in the type of the name. Sorry, the name of the type.
The name of the type. And we want the dynamic, so name.
Yes, but
Yes.
name is, of course, it actually is a name. I now thought it was some name symbol or something. Okay, no, that's actually a string, so that's cool. And how do we get the language of the attribute? Well, maybe let's also do this later. Let's just say language is to do for now. Let's see if our code works so far.
But why do we not want the language of the type?
Yeah, we'll follow up with that. Just want to see how far our code works currently.
Okay.
We need to pass on the compilation.
Okay.
Nothing. That's not too much. That's
okay. We didn't crash.
We didn't. Well, that's yeah, that's correct. I'm not sure if it's good though. Because if we would be crashing, then we would know what's going on.
That's true.
Because then we would at least have
I would at least have a breadcrumb or something.
Yeah, some stack
Okay, great.
trace, yeah. But we got nothing.
Nothing.
So I'm wondering how far we get, or where we exit. Oh, probably our type finding logic does not find anything here. So we may be walking. Yes. Let's see what types that we have found in general. Does not exist in the current context. Well, that's saddening.
That is saddening.
So we found, okay, we seem to have found parse input options. Okay, this is actually the suppressor that we gonna analyze for now, because we commented out the other types, so we should at least find this one. Do we never, is reference type true? Oh, yes. Because we check, if it is not a reference type, then we continue, because we want to find reference types and not ignore reference types. We only have reference types, so we'd find nothing. Okay, but we still find nothing.
Nothing. Oh no. Okay.
Oh, there's something wrong with the debugger, because we apparently halted, but I don't see where we are. Also, I zoomed in a little bit too. No, I'm not sure. I need the. Oh, it's still.
Oh.
There we go.
What is? Oh.
Okay. Nothing is hit.
Nothing. Okay.
Do we await correctly? Something seems wrong. We do await, yeah, so that should be good. I wonder where we fall through. Okay, just nothing is found. Yeah. Okay, so we don't run into any exception. Wait a second. Do we never hit this? Does this mean
We didn't?
First we made this?
If
Something's troubling me. It wasn't working because it was not negated. Now we negated it and it's still not working. That's true, yes.
Oh, what? We're not. We should be in line 101.
Yes.
Right? Okay. Continue. Should we just get rid of the check? Just get rid of it.
Let's get rid of the check.
Just for now. Just for now.
Something is off.
I know, right? This is like, as inspectors, if you don't leave us any clues, what are we gonna do? Nothing. Okay.
Something is severely off. I'm wondering
Reload.
if it has to do with our Let's do a .NET run. Oh yeah, well here we get. It seems that the exception was swallowed by the. Yeah, I guess we need to restart our solution, our tooling here. But
no.
I got something wrong. Maybe related. Yeah, it seems to be when we hop onto a Code with Me session, then after some time stuff gets weird. Yeah, maybe related.
But we were doing so well today. We didn't have any weird so far. Not too much weirdness.
No,
okay.
No, it starts. So, well, I guess because the check is
time.
good. I hope.
Check is good.
Let's do now good old .NET Run.
Yes.
And this should now show the exception. Yes. So we don't find the type.
Yes.
Okay. Yes, because we currently only load into our ad hoc project. We only add the essentially this project as a metadata reference. But this project has a dependency on Microsoft Code Analysis.C#, which is now missing. So we need to add another metadata reference.
Yep. Yes. Second.
To that project. I don't think we need to have
more.
Which now is essentially Roslyn. So we need to add Roslyn as a metadata reference.
Okay, Roslyn metadata reference then.
Yes, because that one is missing.
Yes.
Since we didn't load the Roslyn dependency.
Yeah.
So again, yeah, metadata reference dot create. I think this time we can create from.
Oops.
I'm just
No.
using
Okay.
the.
Something is.
No, it should work because it
Oh.
was using the variable name, not the type name. We should now create from.
Oh, that makes sense then.
Maybe let's create from file, and we
Yes.
just do a type of here, because we using the Roslyn type.
Type of here.
Yes, and let's use exactly the type that we're gonna need, because we need diagnostic suppressor. So let's say type of diagnostic suppressor.
Diagnostic suppressor.
And this requires from file, I think requires a location, a path. So let's say dot location, which is the path to that assembly.
Dot. No.
But after the type of, yeah. Because
No.
location is a member
Dot.
of the type.
Locate. Low.
Is it location, or is it maybe something like path, or?
I don't see anything. Path. Location. Oh. Lolo.
As dot assembly dot location. My bad. The type itself doesn't have a location, no, but the assembly that this type is contained in has, yeah.
The
I
type
suppose
doesn't have a location?
The type
not?
doesn't have a location, no.
Oh, okay.
Because the type lives in an assembly which has a location. Well,
Okay.
also not necessarily.
But could.
If we put that assembly to disk, then yes, you could also have an in-memory assembly. Then it does not have a location.
Okay.
I guess this is why location actually is. Oh no, it's not nullable.
Oh no.
Never mind.
Symbol
yeah,
assembly.
Well, yes, because we banned the assembly symbols. Yeah. I guess we would need to allow them again for this case. But now, yeah, let's then also add this metadata reference. And let's see how far we get now. Because now we should have this type loaded and find that type. Unless we don't. Diagnostic suppressor still not found. Why is that? Is it because does compilation? We have the compilation. If we say get type by metadata name, maybe this only returns types that are declared in the project, but not from metadata reference. I think that's the issue. I think that's the issue. What we could do instead is just check names. Maybe that's the way to go. So instead of doing because I think the problem is, well, we do have the project, the required assembly, which is the Roslyn assembly, now loaded in the same project. So this should be part of the compilation, but we only get types from the project itself, not from references, I think. And for that, we would need to do, I suppose, this get types again, like what we do here. Well, maybe this would actually work. So if we say, so we would need to get the type symbol out of, because we asked the compilation to get the assembly or module symbol for that metadata reference. So I think we would need to do something similar, but for this Roslyn metadata reference. And essentially ask this one for the types. Oops. And how can we do that? Since we have, I guess we need to do something similar, but only with, well, there will be only one, essentially. Let's quickly draft a method. Let's say we only get a type of a particular name. So we would again need to check all of them and say if that member name, yeah, but we need the full name.
Yeah.
Because name is only, do we need to check like namespace? But the containing name, if we say containing namespace dot to string, can we do that? Or to display string and say if this one is the namespace we're looking for and the member name is the name we are looking for. Then and only then do we return this type. So there can be only one. Oh, this member, which is a named type symbol. And the named type symbol, oh, because it's still an iterator method, yes. So we do the same down here as well. And I wonder if that works. If we can for this, oh, we would need to do something similar again. Oh, yeah, okay. Wait a second. We are not entering this, right? We are entering this block. So we would need to again extract if Roslyn is a assembly symbol. Then
Oh my goodness. This is like,
yeah. Microsoft Code is .C#, yes. And other, oops, Roslyn, yes. Otherwise, we essentially do the same again, but only for one type. I module. And then we would need to pass that down as well, which is now the type that we match for. I type symbol. This is now the suppressor type. Okay, naming is now not good, but let's just see if that would work. And so we don't compare against this one, but compare about the type that we get in, which now may or may not work. Damn it. Right. Yes, we need to pass down the, just pass null here because we're not going to enter this here anyway. For now. Oh, this code gets a bit messy. Yes, so in the else block, we just throw. This should never happen. Unreachable.
oh, no, something else. It's not compiling.
Oh, right. Throw new. This should also be, well, this may be, this is an invalid operation exception because we didn't find the type. We could say namespace dot name type not found. This may be a little bit too complicated. Perhaps we solve this differently, but just to, now I want to know if that would work.
Yeah.
At least to some degree. Diagnostic suppressor not found.
Oh, come
not.
on. Why?
Apparently not. Wait, how is this now? Oh, wait a second. Do we now actually enter? The other block now. Okay, I'll just copy paste this up here and pass found here. So a bit messy, but we'll definitely simplify this off stream. But just to see if it works out. Oh, wait, we said we need to do this one, right?
Yeah. I'm like super impressed how you can kind of like, because I like I'm to be honest a little bit lost even, and I'm always super impressed how you can kind of keep like your head in a game.
Well, I guess I'm lost too, because we don't get anything.
Okay.
At least it doesn't query hash, but we get nothing.
Nothing.
So maybe
Great.
this way that we try to find the types kind of does not work. So maybe let's simplify.
Yes.
Let's, instead of doing the type check, maybe let's just check for names. So maybe we can ask the base type namespace So, first of all, the base type may be null.
Okay.
So we need to check, is the base type not null? And, well, actually, I think if it's not null, and if the containing namespace is, okay, now this is the type that we want to search for.
Okay.
So is the containing namespace of the type diagnostics? And is the containing namespace, damn it, why is there no containing namespace? Because that's kind of recursive. Oh, we need another. Now I know. We need another. And no, wait a second. How do we combine patterns? Is it and? If the contain, damn it. I forgot. We did talk about pattern matching, huh? Where we do a little bit. Have we?
No. Well, yeah, a little bit. We did talk a little bit about pattern matching, but we talked more about C# patterns.
Yeah. Oh, the patterns. Yes, not pattern matching. My bad. Yeah. If the namespace is diagnostic.
It's just a little hint because we're going to talk about it very soon again. But if you want to know when and where, you'll have to stay until the very end.
How do we get pattern matching going on now? I want to check now if the containing namespace. Oh, wait a second. Containing namespace.name. If the containing namespace is. Does this work? No.
No.
Containing namespace colon. Okay. Oh, wait. So now, if the containing namespace is something that has a name of, what was it? Damn it. Diagnostic. Right?
Diagnostics.
Diagnostics. Okay. Diagnostics.
Yeah. And.
It has a containing namespace.
There it is.
Not the recursion, but the yeah. And then if this containing namespace has a name of code analysis, yes, I guess we can find a helper method for that. But and okay, now I messed it up.
No, it'll never get out of it. Okay.
No, and if the has a name and a containing namespace
with the name.
Exactly. Has a name of Microsoft. Which now should be kind of the root. That means it should also have a containing namespace
of null.
Exactly. This is not how it works. If the containing namespace is
no. I think semicolon null.
Very good.
Yes.
And also we need to check if the type, no, the base
Oh
type.
my goodness.
So the base type is something, which is now the base.
Okay. I just
And
want to
if
say,
the
I love
base-
how we started this with, let's simplify.
Okay, yeah, you're right. That it's not good. It's not simplifying at all. Is
Yeah.
diagnostic suppressor.
Okay.
But yeah, I'm quite uncertain if
Yeah.
this works. Let's do a couple of woohoos if this
Yeah,
really works.
yeah, definitely. Your
Happy to-
bets can be placed now. Oh my
No,
goodness.
of course it doesn't.
Oh, wait. There was a woohoo
wait.
though.
There was a
I'll put
woohoo.
it in. Oh,
No,
table.
no, that's just a warning that we shouldn't use console white line with just a string here.
Oh, awesome. Okay. Okay.
I was hoping
Let's
this was
simplify.
let's simplify. Does this even work in the first place?
Yeah, exactly.
And
Exactly.
we get. So let's. Yeah, now I know what you mean. Yeah. Well, is the base type is not null?
Exactly.
Then you say not null. Okay, let's do step by step.
Not now woohoo. Okay.
Not null. Woohoo.
Woohoo.
Okay, good old. Since the debugger has left us, good old printf debugging. Actually, we don't even format; it's just print debugging.
Oh.
Okay, cool. So that works. So we have a base type.
Yes.
And would this base type be in a namespace?
Yeah.
That is called diagnostics.
Oh.
It would be two. We actually find, yeah, okay. Yes,
Okay.
it would be.
Mhm.
Yeah,
Yes.
kind of then. Oh, wait a second. The containing namespace. Haha. The containing namespace of the root is not null. It's the global namespace.
Global.
So is
Oh
that
my goodness.
namespace? My bad.
Global.
Is global namespace true?
Easy.
And then the namespace of this namespace then would be null.
No. Nice. But we're not gonna add that. It's already simple enough. Woohoo!
Okay, I'm getting a little bit insane now. That's okay. Woohoo. Okay. Yes, that actually kind of works. No, that does work now. It works. We find the type. Okay, something is wrong with well, yes, because our output, our program currently still uses the old information, but if we update it and say, hey, for a suppressor Roslyn info, woohoo, we get the name.
Yep.
And it actually can support languages. So this should be languages. Let's change the languages. And this should be an immutable array of string.
Yeah.
Is the we'd only select it's just strings. So we should now get actually, unless we have another compiler error. Oh yeah, to do, because it's an immutable array. Let's say default for now. Oops. So now this should print no. Does not contain definition for attribute and no accessible extension method for attribute except in the first argument of support. Wait, that's a compiler error.
What?
Yeah.
Oh.
It's just languages, my bad.
I also didn't see it.
Wait.
That's weird. But I think,
yeah. Huh? Don't we have language?
No.
So languages. I didn't rename the. I should have used the rename refactoring. Yes.
Yes. Some keyboard shortcuts.
Oh, we're getting there, yeah. No.
No. Okay. Oh my goodness. Program. What? Oh,
I don't see a way. So I could go here, right?
yeah. Oh, it's again a
Languages.
language.
Did we not say languages here? Did I not see languages? I
Yeah,
guess I am
no.
getting insane now.
No, there
Maybe I
was
didn't.
definitely languages, but I don't know what's going on.
Okay. This operation
Okay.
cannot be performed because yes. Okay. Because we say default.
I don't even know
In
how to
immutable array of
read that so
default.
fast. Yeah.
Well, we now get an exception because we are doing a string. We are enumerating through an immutable array that is default, and that doesn't work. That was a one-time
Why?
exception. What we need to say is an empty array. Immutable array.
What? Wait, what?
Immutable array of string.
We want to
empty. This will now we have something
iterate
empty.
over an empty array, but not a default
Yes.
array?
If we say
that's
default,
null and not empty. No.
No. You know what? Let's come to that because this is a
Let's
bit
simplify.
of a. This is a bit of a. You know
Yeah?
what?
What is
Next
it? We're
episode, we're gonna talk about this
Oh, really?
because that's a bit immutable array has a bit of a pitfall. So let's talk about why, if we try to iterate through a immutable array, is not a class; it's a struct. So it can never be null. But if we try to iterate through a default array without some checks, it will fail. Why that is, we will go into with the next episode. So immutable array has some pitfalls. It is super high performance. It is the fastest thing you can have over an array to make it immutable. But it has its pitfalls. But there we go. It now works.
Which supports nothing with nothing. That's lovely.
Yes. Because, well, so we can get with this use. So our logic now works. Or we do it twice. Yeah. Oh, that's why it was weird, because we had it twice and only once was
interesting for us.
So the only step left, which you then would apply to all of the others as well, to analyzers, generators, and so on, is now extract the language of the attribute. So we do get, well, we know we do find the attribute.
Yes.
So I suppose we actually need to get that attribute. So maybe, would you like to take over again? So instead of saying any, we need to say
select. No. Select.
There should be only one. So we get either first or default or single or default. Store that in a local variable.
No.
So we need to put now. No, that's okay, but it's not returning a Boolean, so it doesn't work within an if anymore. So you maybe now you could use the new shortcut to select everything that is within the if clause. Is that the clause?
Yes.
Maybe you can do Alt-Enter and extract it to a local field, if that refactoring
Oh my
works.
goodness. Waiting for context actions. So we could be aware. I'll try again. Yeah, you do it.
So refactor to a field. Yeah, first or default, although it's not underscore. And here we just check, is this not null? Because first or default will return default if it's not found. Wait a second. Oh, it turned this into a field. I wanted to turn this into a local variable or into a field. This needs to be, we need to split this up. I guess we can, this logic where we extract types, we can put into a separate type. Bit of a helper type, extension method, something. Cool. And now, well, this would be the attribute. And okay, now we need to extract the language information out of the attribute.
Yes. Dot language.
No, that's not how it works because we don't know.
Get language. Get type. Sorry.
We know this attribute.
Yes.
But we don't know, because we don't know the type. We don't know this is the type diagnostic analyzer of which we can now call dot languages.
Languages.
This doesn't work. Because this is not initialized, we only look at it from a symbol perspective. So what we do need to do, what we do know though, is how this symbol looks like. So we should be able to inspect like the first argument. So we actually see this, I think. So we should be able to kind of inspect this argument and turn this into a string, I think. So I'm wondering what the correct
attribute.
I wonder if constructor arguments is the correct thing.
Oops. Yes.
And get the first one of that, or we could do something similar again, first or default.
Yes.
Or wait a second, constructor arguments. Wait a second. This is the. Why did I close it? This is the diagnostic analyzer attribute. And it takes a first language and then a second parameter additional languages. Okay, I'm not sure how to deal with the array, but let's deal with the first language now.
Yeah.
And yeah, so we get the first.
Yeah.
And if it has one, or maybe let's be aggressive. Let's say single for now. So we kind of require exactly one.
Really? Can I single?
No. Instead of the first to default, you can say single.
Oh, first to default.
This will fail if it's not exactly a single one. So if it's 0 or many,
so if we have additional languages,
it will fail. Yes, but just for now, then get the value of this into some. Yeah.
You mean arg? No.
Yeah.
Language.
And now, what does arg? No, we won't find dot language. But let's see what arg. This is of typed constant. Ooh, typed constant. That's good. Because
value.
That's a constant, and of one constant, we should get a value, exactly. So let's say we now, instead of here, say immutable array dot create and pass in the value. What is value? That is an object. Yeah, I guess we can just toString this.
Easy.
Because we know it's a string. Object may be null. Okay, let's not deal with null warnings now. Otherwise, it would be a bit longer. But let's see if we now get the language. Oh, no.
No.
Sequence contains more than one element. Okay.
No.
So the single fails. We actually have more than one already. Okay, then let's do first.
Easy. All right.
I wonder what the other one is. Object reference to an instance of the object. Damn, so it doesn't have a value. That's saddening. Is it null? Maybe we can.
Probably the second argument.
Let's go through the arguments
that we want. Oh, why? Okay.
Just to get it compiling, I'm now wondering.
Yeah.
Because we also get more than one, so I'm actually quite not sure what we get here. We get
unhandled.
What does it now say? What? Oh, yeah, the single. My bad.
Oh, yeah.
First. Okay, so we actually we get two typed constants. I wonder what we can ask of these typed constants. Maybe the kind.
Value.
Let's get the kind and the value.
All right. All right.
Ooh, it's an error type. Damn.
Oh, come on. What? How does that happen?
Okay, maybe we can't. Maybe this doesn't work. Damn it. I thought we could, but apparently we can't. I was wondering, maybe we can debug it, because that would be super helpful.
Yeah.
Just want to hit this breakpoint, please. Yes, cool.
Yes.
Because we should be able to inspect this attribute and see what we get. Okay, well, attribute data, that's a syntax reference. Yeah, we don't have any syntax because we don't have the source code to it. We have some attribute. Well, we know the class. We all checked that already. That's the type. Can we find it somewhere here? Microsoft Code Analysis Diagnostics namespace. Attribute constructor. Yeah, but we don't necessarily need the constructor. Yeah, the constructor takes two parameters, the language and the additional language. We know the constructor arguments. Oh, okay. One is an error. Error type system string. Damn it, so we can't get the value. And the second one is an array. No, it seems we can't get that data. That's discouraging.
Okay. Okay. And we need it for the language.
Yes.
So any other
I was
way?
hoping that we can get via the constructor arguments. Yeah, so there is two arguments. One is in the second language, the array. The second one is, but the kind is an error. That means we don't know. Yeah, something. So something fails during compilation, it seems. Ooh.
Yes. What is it?
I have an idea.
Spit it out.
We load our Roslyn component.
Yes.
Cool. We also load the Roslyn assembly. But the Roslyn assembly kind of, okay, I'm not sure if this is really visible on stream.
What?
Oh, I can do
the writing.
Okay.
Oh,
So
this is better. Yep.
we load the Roslyn component, which has the diagnostic suppressor. This assembly depends on Microsoft.codeanalysis.C#, which in turn depends on, I think, Microsoft.codeanalysis.common, which in turn depends on something of the BCL. Well, we do load the Roslyn assembly, but we do not load the BCL. So we do not load the attribute type, essentially. So what we should be able to do is kind of also create, well, the BCL, that's where the object lives, what I mentioned earlier, the core lib. We could be a little bit more specific because what we need is the attribute in our case. And let's see if this is changing something in that story.
Okay.
It does, because now we can notice.
Yes!
Now we can actually construct this attribute. The attribute type was missing because the attribute is based.
Yeah.
The base type of the diagnostic suppressor attribute is attribute, but we didn't load the attribute type. Or we didn't have a reference to this attribute type. We essentially
That's really good.
missed a reference to the BCL, which we now have. So we can now.
Good spot.
Is the breakpoint still there? So we should now be able to actually get. Now it's no longer an error because we now know it can actually be compiled. Because you get an error type if something was not creatable and not loadable. And now we know one is an array, which is still some invalid exception, but probably we're still missing something. But the value There it is, C#.
It's C#. Easy.
And so we know the first typed argument. We know, well, that's a primitive. So that's string and int and all of them. We actually know the type, it's a string. So we should be able to toString this. And for the second one, because we know it has actually 2 arguments, the second argument, that's an array. So that's actually the thing. It doesn't have a value because it's an array. It has values indeed. Well, these are empty, but it could have more than 1. So if we now say var languages, what do we create? Let's create an immutable array of string. Well, let's create a builder. And we add the attribute constructor arguments, the first one, which we know is a value.
toString.
Yes, because value is just object. I guess what we could additionally check is the type. Is the type really a string? And is it not null? And is it not an array? Because if it's an array, we should access values. But yeah, let's assume we did all of the checks correctly. Let's suppress the nullability warning here and here. And the second index would be values, which we also toString. So we select them, say .toString, which, because it's add range, not add. And again, we suppress the nullable warnings.
Yep.
And now we should be able to say, to pass dot to immutable. Immutable.
Okay.
So we now create an immutable array of languages, and this might just work.
Okay.
Roslyn is fun. There we go. There we go. And if we had additional languages, let's say we add Visual Basic, and we also add F#.
Yep.
Would we now get all 3? No, we wouldn't. Why would we not? Oh, I didn't rebuild. I think I need to rebuild because we don't have a direct reference.
Yes. It's very insane. Yeah, a little bit insane over here as well. What?
No, I just want to get this. Oh, why not? Warum nicht?
Yep. Some German sprinkled in here as well.
Oh, wait a second. Yeah, because I was updating the analyzer, not the suppressor. We only added layer 8 issue, skill issue. We currently only have the logic for the suppressor. Now we updated the suppressor to support all of the languages. Well, it doesn't, but we are lying. We say it does. And now we should just get 3 languages.
All right, bets are on.
Okay, well, we're doing something wrong because the values are again, okay. So the values, again, are typed constants. So we need to ask the value of the values.
Okay.
Now I'm fairly confident.
Confident, same.
And
easy.
There we have it. Now we have a
easy peasy lemon squeezy.
A suppressor that supports all of the languages. And
awesome.
Let's see if our original claim that no more code is executed. Let's go to let's go to the suppressor. Let's say let's throw new not implemented exception. And let's also add, I deleted the module initializer. Let's add the module initializer again.
Okay.
Public static void init. It needs to have the module initializer attribute that we will get again from the trustee. Do we still have it open?
Yep.
Source.net.
Woohoo!
Because we are on .NET Standard, and .NET Standard doesn't have the attribute included, so we need to polyfill it. And what's wrong here? Oh yeah, this should be a block.
Oh.
Now we can, wait, the refactoring trend failed.
Yeah. Okay.
And cool. So, console.writeline, this should not be executed. We did see this before.
Oh. Mm-hmm. Oh.
Because
No.
the API is banned, let's ignore. Okay. We did see this before when we were using reflection. That code was executed.
We did
Let's
indeed.
see if our claim is correct.
Oh my goodness.
If it doesn't any more.
All right.
It would be fun. You know, it would be funny if it would. And all of that would have been for nothing. But it doesn't.
We don't share the same sense of humor all of the time. I think that would have been so sad. You would have seen my single tear. Yeah. What?
So the
What do you
constructor isn't. Excuse me.
Yes.
The constructor
Sorry.
isn't executed. The property it would not be executed even if we were doing some. Some shenanigans like directory.delete. I don't know. Well, this doesn't work, does it? I don't know if it would. Oh, this is also a banned API, right? Yes, but not today. So you could delete some user. I'm not sure. On Unix systems, you have something like this. I'm super bad. Yeah.
Yeah. So bad.
This is not, but something like that, or extract all environment variables and secrets from the machine to somewhere. Yeah, so this code will, even if it was there, it would no longer be executed because we avoid actually instantiating the stuff. We just analyze it from the metadata perspective without creating instances of it. And I thought the code was a little bit simpler, but it's not. Oh, there we go. So the Roslyn APIs are a bit more. Well, they're super detailed because you get so much information, and we check for the base type. Oh yeah, we don't have the code for the base type. What we would need to do is essentially turn this into a loop, and if this fails on the base type, then check for the base type of the base type, and if this fails, check for the base type of the base type of the base type, until check base of base until the base type is object, because we know the object is not that type we're looking for, and that's the root, or we just go until the base is null. If we go until the base is null, we would eventually also check the object base type, which can never be true. So it would be a bit of an optimization to check if the base type is object, then we stop, because that's the root of all. And that would be the only thing to do here. And then apply all of this, I guess, extracting some helper methods, and then apply all of this for analyzers, source generators, code fix providers, refactorings, completion providers as well, which we will do off stream. And then our Inspector Roslyn is, I'm not sure if I dare to say safe, but
No, safer.
or significantly safer.
Definitely significantly safer. We've eliminated one of the risks.
Yes.
That's really cool. That's really cool. Actually, that's really cool. I mean, because we was talking about the episode, and I think we were talking about this issue a little bit before as well. But before then, I didn't even know this was possible. Like, I would have never thought of it. And again, like, I'm super, super impressed because I think I followed pretty strongly right at the beginning, and there was some point where I was like completely lost, and you weren't, and that's really cool.
Well,
So
to
well
be fair,
done.
we don't need any of this. We did then pick up the pace a little bit to be somewhat, because today's the first time we totally overshoot. Well, not totally, it's still within.
Well, not totally. I think yes, for this
Slightly.
season it is the longest episode so far. But you know what? We're doing all right. I'm gonna give us that. And I think it was a good tangent. Usually, sometimes we go on ridiculous tangents that don't make any sense with the not really so connected to the issue that we're having, just because we're having fun and we want to know more. But this one is really like, you can, we have an excuse to go on a tangent here. Yeah.
And I guess the bit of the takeaway is when we build our own ad hoc workspace up here, it's empty. It doesn't have anything. So we need to add even the base class library and all of because the Roslyn component itself, we say, okay, it's depending on that standard 2.0. This one is, it has a package reference to this, but it's not part of it. It's just, it has these dependencies, and we kind of need to restore them. So to be super precise, what we could maybe do later, because currently we assume that it requires these. If it was depending on something else, we would fail because dependency is missing, but we do have an issue for that. To tighten this, but we kind of need to look into it. What dependencies does it have? And then, we store the project, essentially. We kind of try to restore the project, more or less, how it originally was, so that we then can inspect the symbols to a certain fidelity. If that makes sense.
Yes.
Partially,
definitely. What is it?
Völlig verschwitzt.
Yes. That's a tough one, but we got through it. And I guess if you enjoyed watching and helping us work on Inspector Roslyn, I think this is also going to be probably a project for the entire season. And because sometimes we have like many small projects, and this season we're very consistent with Inspector Roslyn, but there's loads more to discover, and many more features to add. So once again, please give us a follow on any of our social media channels. Oh my goodness, it is late. Social media channels, just to keep up to date with our upcoming contents and our upcoming episodes. Again, we are usually pretty consistent, but you wouldn't want to miss an episode. And if you do, you can always rewatch them on YouTube.
Oh yeah.
But right, actually, to be completely frank, next time, because if you've been with us, what is it? If you've been with us for a couple of years, you know that we love to have an April Fool's episode.
Oh yeah.
And so the plan is not to hit the 1st of April this time, but actually the 31st. But yeah, so I just wanted to give a little bit of a sneak peek of the next episode, because it could be a really fun one. And yeah, it's usually maybe a little bit different from what our usual content is. It's just to show you some really nice quirks of .NET, C#, things like that, right?
One of
Is that
which
right?
will
Is that
be
fair
the
to say?
quirks of immutable array. Yeah.
Exactly. Oh yeah, we did tease it already. There you go. I could have segued like that. But also, if you want to see us a little bit sooner
Oh,
and you
yes.
happen to be in Vienna, we are actually also having a little talk at the .NET Devs meetup in Vienna. I do believe you can also join remotely. Is that right?
Yet. Yes.
Yet?
Yes.
Yeah, yet you can join. Yes. So, but if you're in the area, obviously, come along. It's free. You can just sign on, and you can say hi. And yeah, we would love to see you there. Actually, that would be
Yes, so
really really cool.
Oh, that's
You also
actually
need to be super kind because. Again, if you've been here before, you know that I get very nervous. And if I get nervous in front of a camera, you can only imagine my heart rate when I'm standing in front of actual people. It's terrifying. So you don't want to miss that.
Ooh.
Yeah, so
Ooh.
either come along.
Is
What is it?
your salty devil not missing it?
Yes, I suppose he's not. I guess he's not.
Is that amazing or
And
terrifying? I'm not sure.
yeah, both. No. It's emotional support. Yeah, I guess I think all of our viewers would come and support me, right? Not scare me, right? That would be horrible. No, it's going to be really good fun. It's going to be good fun either way. I think it's a really great talk. I always really have fun talking about this kind of stuff, and the .NET meetup in Vienna is actually always really really good fun. I do like to go there quite regularly, and yeah, I don't think I've ever had a bad one. So that's really really good. And yeah, so that's next week. That's a week from now. That's terrifying.
Oh yeah. Well, in a
Great.
week from now, it's over already.
Over already. It's already plop.
in a week. Yeah, exactly. We are in a week from now. We are already in the after party.
Party.
Try to search for a more serious word, but I couldn't come up with one.
No,
debriefing.
Exactly. We're going to be in a debriefing in a very serious with the bow tie. And yeah, no, I'm actually really looking forward to it. It's also the cool venue that I've never been to.
Ooh.
Right?
Oh yeah, it is a cool venue.
Yes.
Yes, indeed.
And also, if you come along, you can win some really awesome prizes. Both, like, yeah.
Oh yeah.
But anyway, you'll have to come and see it for yourself.
I just got the swag already in store, so it's all prepared. Yeah.
Did you?
Yeah.
Amazing. Right. I think we have gone a little bit insane.
Just a little bit.
When is our next
this is
stream?
What Roslyn does to you. So yeah, we'll be back in person on the 24th, but also online. Yeah, and our next stream will be in a week on March the 31st, where we will already deviate a little bit from Inspector Roslyn. Yeah, as mentioned, some pitfalls will be analyzed, such as the immutable array.
All right. Well, thanks again for joining us and spending your Tuesday evening with us, or whatever time it is for wherever you're viewing from. No, it means the world to me. I had a lot of fun, and I did learn quite a few things. So I had a good one. Thank you so much.
Well, likewise for me. And until then, we'll be back.